Each year, more than 20 million tons of olives are transformed into the liquid gold that sustains the Mediterranean. Yet when eaten fresh, these fruits are bitter to the point that only birds can swallow them. So how did humanity manage to turn them into familiar products like salted olives, extra virgin olive oil, and even fragrant bars of soap? The journey begins in olive groves that can live for thousands of years. After harvest, the fruits enter a miraculous chain of transformations on modern production lines, reborn as crunchy salted olives, precious golden olive oil, and smooth, aromatic soap, carrying flavors and values far greater than their small size. Today, let agricultural insight immerse you in that green, pungent bitterness to uncover the fascinating stories hidden behind every olive-based product you use. All will be revealed right now. Have you ever noticed that the United Nations logo is encircled by two olive branches, a timeless symbol of peace and hope? Yet beyond that sacred meaning, on the global marketplace, olives ignite a fierce competition worth as much as $14 billion. Spain dominates production like a giant, while Italy, Greece, Turkey, and even North Africa strive to carve out their own marks, from specialty varieties and processing techniques to bold export strategies. So, what makes olives such a coveted treasure, relentlessly pursued by the world? What sets them apart from so many other fruits lies in their wealth of heart-protective healthy fats, combined with vitamin E's powerful antioxidant effects, and a range of minerals that fight inflammation and slow down aging. But the price of producing this high-quality nutrition is far from small. To make just 1 liter of olive oil requires up to 4,000 liters of water, a water footprint equivalent to brewing 20,000 cups of coffee. And to truly grasp this paradoxical journey, let us follow from the silvery groves to the harvest itself, where the secrets of olives first begin to unfold. Each year, the olive harvest stretches from early autumn to late winter, when the fruits ripen, glossy and full of oil and nutrients. No grower dares to miss this golden moment. But to turn that season of abundance into reality, human hands alone are not enough. In super high-density olive orchards, the only viable alternative to the impossible task of hand-picking is the massive straddle harvester, a machine designed like a moving tunnel that engulfs entire rows of trees. With its gripping and shaking system, the machine sweeps along the row, shaking olives down in torrents. The fruits drop into catch trays, then move straight onto conveyor belts. Leaves and twigs are sucked up and filtered out inside the machine, leaving only clean olives ready to be funneled into accompanying storage bins. Thanks to this process, entire rows can be harvested clean in just minutes. Dozens of times faster than hand-picking, while reducing the risk of fruit touching the ground by up to 95%, thus preserving quality. However, to use this machine, olive trees must be planted in perfectly straight, orderly rows. So what about smaller olive groves, just a few dozen hectares in size? The main solution is the tree shaker. This machine works quite simply. A hydraulic arm grips the tree trunk tightly and shakes it vigorously, causing the olives to fall all at once. Below, large nets are spread out to catch the fruits, which farmers then gather up. This method is well suited for older olive groves, where trees are spaced nearly 10 meters apart, with straight trunks, strong roots, and a large enough diameter for a firm grip. However, the ground also needs to be relatively flat for the machine to operate efficiently. A single tree that would take 4 or 5 people nearly an hour to pick by hand can now be harvested in less than a minute. Still, the intense shaking can cause leaves to fall, young branches to snap, and in the long run, may weaken the tree. For this reason, many orchards opt for a combination, using hand poles to select fruits at the perfect ripeness while keeping the trees healthy, and at the same time relying on machines to speed up the harvest. Yet whether by human hands or by machines, the key to survival after harvest is speed. Olives must be taken to the mill immediately, because just a few hours' delay triggers oxidation. Aromas begin to fade, bitterness rises, and quality quickly declines. When crates of olives arrive, forklifts receive them and carefully pour them into the intake hopper. Here, dry leaves and twigs are removed in the first step. Only those that pass the test continue along the conveyor belt, beginning a more thorough cleaning process. At the other end, a chilled, bubbling tank awaits the olives. The swirling water washes away soil and dust clinging to their skins. Then a row of overhead sprayers rains down like a gentle shower, leaving each fruit plump, fresh, and gleaming, fully prepared for its transformation before reaching the consumer. Olives are naturally sharp and bitter, so to make them edible, people rely on salt and fermentation. That is why the very first step is always traditional debitoring. Immediately afterward, the fruits are placed into giant brine tanks, where they rest for 3 to 4 months to undergo natural fermentation. During this time, lactic acid bacteria quietly mellow the harsh flavor, while adding a subtle tanginess and the signature crunch, the foundation for every stage of processing that follows. Once fermentation is complete, the olives are heat-treated to stabilize their texture and flavor before moving on to size grading. This step not only eliminates cracked, damaged, or low-quality fruits, but also ensures perfect uniformity for stuffing and packaging. Such consistency not only enhances the product's visual appeal when it reaches consumers, but also preserves its high commercial value on the market. On modern production lines, olive pits are removed and replaced with flavorful fillings such as chili, almonds, lemon, or rich pâté. Immediately after, the fruits pass through a washing system and a densimeter to remove any remaining pit fragments and broken olives. This washing stage not only cleans the product but also balances salinity and softens the sharp acidity, ensuring the uniform taste required before packaging. They are then moved to the final stage, packaging. The fruits are arranged in glass jars or metal cans, where filling machines precisely adjust the volume, adding brine and seasonings tailored to each market's preference. The US tends to favor larger cans with bold flavors. Japan prefers smaller jars with milder tastes, while Europe remains loyal to its traditional style. Finally, the products are vacuum-sealed, sterilized on-site, and stacked on pallets, ready to embark on journeys that carry them across the globe. To turn olives into oil, the first step is crushing. Inside a sealed chamber, a rotating shaft with steel hammers smashes the flesh, skin, and pits. If the pits crack just right, they add flavor and texture. Too much, and the oil turns harshly bitter. In just half an hour, 5 tons of olives become a thick paste, a blend of oil, water, and solids. But this paste can't be pressed yet. It must go through malaxation, a slow mixing process lasting 20 to 40 minutes at a warm temperature. This allows tiny droplets of oil to merge into larger ones, ready for separation, while natural enzymes weave notes of grass, apple, pepper, and almond. Many describe this as the olive's meditative state before they transform in the next stage of extraction. Inside the state-of-the-art decanter, a screw conveyor turns slowly but firmly, pressing and pushing the olive paste into a high-speed spin. Thanks to centrifugal force, the oil, being lighter, separates completely from the water and solid pulp. From here, the first streams of raw olive oil begin to flow. But don't mistake it for shimmering golden right away. Instead, the olive oil Freshly extracted, the oil is often emerald green, slightly cloudy, and only later turns clear and golden after filtering. At this stage, some producers filter further to remove fine particles, achieving a crystal clear hue. Others prefer to leave a touch of rustic character for a richer flavor. Either way, the end result is the same: luscious drops of liquid essence, the distilled reward of a painstaking journey. In the final stage, each glass bottle is filled with silky oil, capped tightly as it spins through sealing machines, then glides past labeling lines and inspection lights. A quick heat seal sterilization closes the process before sturdy cartons are packed and sealed. From there, the purest bottles of olive oil are ready to travel into supermarkets, restaurants, and kitchens across the globe, completing the journey from bitter fruit on the branch to the flavor inseparable from Mediterranean cuisine. But not every olive ends up that way. Guess what happens if the paste, instead of going to oil extraction, is cooked with caustic soda and water? This is the crucial difference between making oil and making soap. It's not just boiling oil. The saponification reaction is set in motion. Under high heat, fat bonds break apart, then reform into soap. For 3 days, the mixture must be stirred constantly to prevent scorching, with the temperature kept steady so the reaction won't be interrupted. There's also a small but vital trick. Sprinkle dry soap powder on the floor beforehand, so when the vat is drained, the hot solid mass won't stick to the cement. At first, the mixture is thin and pale, then it thickens, darkens to deep green, and turns viscous like boiling honey. That's the moment the oil has died, reborn as soft, pure soap, ready for the next stage. When cooking is done, thick streams of hot, steaming soap spill out, spreading into a glossy green carpet about 6 centimeters thick across the floor. It is then leveled with simple tools to create a smooth surface. The task may look easy, but it's not. Too much force and the soap shifts, too little and the surface ripples. Only experienced hands can find the just right balance. The soap block continues to radiate warmth like an ember, slowly cooling and hardening day by day into a green stone slab. Temperature and humidity in the workshop must be perfectly balanced, or the whole batch risks cracking or turning sticky. Marking and stamping come next, the decisive step that transforms the raw block into a finished product, both perfectly shaped and branded. Before dividing it, workers dust the surface with fine powder to prevent sticking, then stretch dyed cords across it in 7 by 7 centimeter squares, like laying out a giant chessboard. Once the grid is set, cutting begins, the final step that turns the massive slab into neat little bars ready for use. Workers operate a rake-like cutting frame, long and heavy, strung with taut wires. They don't just use their arms, they lean in with their whole bodies, pressing down to slice through the dense 6 centimeter thick soap. Each pull marks a sharp boundary, splitting the broad slab into even rows of perfect squares. And from there, each rustic block of soap takes on the form of a finished product. After cutting and stamping, the soap bars can't be packed right away. They must go through a long resting stage. Workers stack them into hollow towers, layer upon layer, so the air can circulate evenly. For months, usually 3 to 6, the soap remains still, slowly releasing moisture and hardening day by day. This period decides everything. When cured properly, the bars are dry, solid, and long-lasting, able to endure for years without spoiling. But rush the process, and the soap turns soft, fragile, and quick to wear away. That's why this stage is seen as the final discipline, where each bar of soap completes its transformation before entering the market. So next time you cook with olive oil, savor a pickled olive or wash with that smooth green bar. Remember the extraordinary journey behind it, a story of how people turned bitterness into a timeless treasure. Bean sprouts, mainly mung bean or soybean sprouts, are a type of sprout vegetable with a long history in East Asia, especially in ancient China, before spreading through trade routes to many other cultures. Since ancient times, they have been both a humble food source and regarded in traditional medicine as a healing vegetable that helps clear heat and detoxify the body. Unlike other vegetables that require sunlight to thrive, bean sprouts are grown entirely in the dark to keep their stems white, plump, and crisp. Within just 3 to 7 days, a tiny dry bean can increase in size several times and become edible. Remarkably, during germination, bean sprouts self-generate vitamin C, a nutrient almost absent in dry beans, making them an unexpectedly rich source of nutrition. However, the warm and humid environment that favors sprout growth is also ideal for bacteria, so although they are often called soil-free vegetables, bean sprouts are generally recommended to be eaten cooked for greater safety. Today, East Asian countries such as Japan, Korea, and China remain leading centers of bean sprout production and consumption. Despite their extremely short life cycle and low market price, the global sprout industry still generates billions of dollars in revenue each year. More importantly, bean sprouts are considered a sole vegetable in many Asian cuisines, appearing everywhere from simple family meals to street food and even fine dining restaurants. In just 100 grams, bean sprouts contain only about 30 kcal, but provide up to 3 grams of protein, along with abundant vitamin C, folate, vitamin K, and fiber. This surprising blend of nutritional value and widespread popularity makes bean sprouts a tiny wonder of the culinary world, simple yet unique and almost irreplaceable among vegetables. Now let's begin our journey of discovery, starting inside large-scale sprout production facilities, where each tiny mung bean is awakened to begin a new life cycle through modern cultivation methods. The very first step, which may seem simple but is absolutely crucial, is seed selection. To produce a batch of white, plump, crisp, sweet, and uniform sprouts, mung beans must be carefully chosen. Only round, firm, evenly sized beans, free from mold, pests, and with a germination rate above 95% are accepted for production. Before use, each batch of seeds undergoes strict quality inspection and is then stored in specialized cold rooms where temperature and humidity are consistently controlled to preserve freshness and germination capacity. When production begins, the seed bags are taken out of storage and poured into a loading hopper, which feeds them directly into warm water tanks maintained at about 35 to 38 degrees Celsius. This soaking stage lasts for several hours, allowing the beans to fully absorb water and swell evenly, while discarding any hollow or damaged beans that float to the surface. The purpose of this process is to awaken growth, activate the embryo inside each seed, and prepare them for the next germination stage. After about 8 to 12 hours of soaking in warm water, the beans are transferred into cool water to be refreshed, then placed into vertical stainless steel cylinders or specialized sprouting trays. From there, they are moved into sealed germination chambers, where the temperature is kept stable at 24 to 28 degrees and the air humidity maintained at 90 to 95%. Throughout the 4 to 6 day germination period, an automated system sprays clean or sterilized water several times a day, keeping the beans moist without flooding them. Light is completely excluded, allowing the sprouts to develop white, crisp, and plump stems. When the sprouts reach a length of about 4 to 6 centimeters, the germination containers, now filled with thick clusters of white sprouts, are transferred to the preliminary processing area. The masses of plump white sprouts are emptied into a collection hopper and sent directly into the automatic pre-processing system. This crucial first step separates the sprouts from the germination environment and prepares them for the cleaning line. As soon as they enter the processing line, the bean sprouts pass through a rotating shaft fitted with steel prongs and scraping teeth. This mechanical motion helps remove the long roots and any remaining seed coats from the sprout stems. As a result, the product gradually becomes cleaner, more uniform, and suitable for commercial presentation. The byproducts, such as roots and seed coats, are collected in large plastic bins for disposal or reuse as animal feed. After the root removal stage, the sprouts continue along a mesh conveyor belt and pass through multiple layers of strong water jets from a high-pressure spraying system. The continuous flow of cold water not only washes away impurities, but also cools the sprouts, helping preserve their crisp texture and natural white color. In certain steps, the sprouts are also soaked in clean water, while vibrating sieves separate out undersized, broken, or substandard sprouts. To ensure food safety, modern production lines are additionally equipped with misting or ozone water spraying systems. This step helps minimize the risk of bacterial contamination and extends shelf life. Rapid cooling directly on the conveyor further enhances freshness retention before packaging. After washing and disinfection, the bean sprouts pass over an inclined mesh conveyor to remove excess water. Streams of compressed air or cool airflow are blown strongly from above, allowing the sprouts to dry quickly without being damaged. At this stage, the sprouts have reached the desired level of cleanliness, whiteness, and crispness, and continue moving along the conveyor to the weighing and packaging area. Here, the bean sprouts are dispensed into a multi-head weigher, an advanced device capable of portioning products with gram-level accuracy. Small hoppers rotate in sequence, opening one after another to release just the right amount of sprouts into collection chutes. Thanks to this process, every finished pack consistently meets the factory's weight standards, typically 200 grams, 500 grams, or 1 kilogram, depending on market demand. Immediately after weighing, the sprouts drop straight into the automatic packaging machine. Pre-rolled food-grade plastic film is cut into segments and opened beneath the filling spout. As the sprouts fall in, the bag opening is clamped shut and sealed by heat. At the same time, the machine can either remove excess air or inject clean gas, nitrogen, to extend shelf life and keep the sprouts fresh and crisp. Finally, all finished products are vacuum-packed, placed into cartons, and stored, ready to be distributed to consumers. But what if you tried growing your own bean sprouts at home? In fact, cultivating bean sprouts is incredibly simple and fun. This sprout vegetable hardly requires any soil, just clean water, darkness, and a little patience, and you'll have a harvest. They can thrive in almost any container, from small pots, bamboo baskets, tin cans, or even cut plastic bottles, as long as there is drainage and no direct exposure to light. The process begins with carefully selected mung beans, round, firm, and free from pests. After soaking the beans in warm water for 6 to 8 hours to allow them to swell, rinse them thoroughly and place them into your chosen container. Then cover with a damp cloth to maintain moisture and block light. Each day, rinse the beans 2 to 3 times to keep them moist but not waterlogged. After about 3 to 4 days, plump white shoots will begin to sprout, and within just 5 to 7 days you can harvest. At that point, simply pull out the sprouts, wash off the roots and seed coats, and they're ready to be enjoyed in your dishes. bean sprouts have long been an indispensable part of Asian culinary culture. In Vietnam, they are a familiar companion in nearly every dish, from iconic specialties like pho, bun bo, and bánh xèo to everyday family meals, always bringing a perfect balance between richness and refreshing crispness. In Thailand, bean sprouts are the soul of the famous pad thai, where each fresh sprout blends with noodles, shrimp, and tamarind sauce to create an unforgettable freshness. In Japan, moyashi are quickly stir-fried or added to ramen, serving as an affordable vegetable embraced by all social classes. Meanwhile, Korea has built an entire food culture around bean sprouts. Sukjunamul from mung bean sprouts and kongnamul from soybean sprouts, most famously in the hangover soup kongnamul guk, often regarded as a true national dish. Beyond being a versatile ingredient, bean sprouts are also popular for their low cost, ease of preparation, and adaptability to many cooking methods. Eaten raw in fresh vegetable assortments, mixed into salads, quickly stir-fried with meat or seafood, or added to hot pots and soups. In any form, they retain their signature crisp freshness, softening strong flavors while adding extra nutrients, making bean sprouts a humble yet irreplaceable sprout vegetable in East Asian cuisine. With a global market value exceeding $6 billion USD annually, broccoli is more than just a vegetable. It's the green gold of high-tech agriculture. China is currently the world's largest broccoli producer, though most of its output is consumed domestically. When it comes to exports, high quality, and advanced farming practices, the United States leads the way. With 90% of production concentrated in California, a state blessed with a Mediterranean climate, loose fertile soil, and a steady water supply, making it ideal for year-round broccoli cultivation. Within the Brassica family, broccoli is often compared to its sibling, cauliflower, but the more you compare, the more the gap becomes clear. While cauliflower is mild and easy to prepare, broccoli stands out with a richer flavor, higher vitamin C content and sulforaphane, a powerful antioxidant compound. It's no surprise that broccoli is increasingly taking center stage in modern diets, from weight loss plans and clean eating to the functional food industry. And like every great story, this one has a beginning. For broccoli, it starts with tiny seeds sown across vast green fields each fall, or whenever the early warmth of spring begins to return. As a cool season crop, broccoli is typically planted during the milder times of the year in temperate regions, and year-round in areas with consistently moderate climates like California. The plant grows best at temperatures between 15 to 20 degrees Celsius, 59 to 68 degrees Fahrenheit. Before planting, the soil should be well-tilled, rich in organic matter, and have a pH between 6.0 and 7.0. Did you know? Despite their different colors and shapes, both broccoli and cauliflower share the same humble beginning. They all grow from a small nursery tray. Once the seedlings are ready, they're placed into a planting machine. As the machine moves, a mechanical system automatically opens rows, places the seedlings into the soil, covers them, and gently presses the base, all in one seamless motion. This mechanized process not only saves time and labor, but also ensures uniform spacing, better growth, and easier care. Thanks to automation, thousands of broccoli plants can be transplanted within just a few hours with near-perfect precision. Although both start from nursery trays and share similar care routines, cauliflower and broccoli have some clear differences. Cauliflower is more fussy. It requires cooler climates, grows more slowly, and needs its leaves tied over the head to prevent sunburn on the curd. Broccoli, on the other hand, is more adaptable. After germination, it needs consistent watering, especially during head formation. It prefers moderate but regular moisture, so drip or overhead irrigation systems are commonly used to maintain humidity and reduce pests. Balanced fertilization, particularly with nitrogen, potassium, and calcium, helps the plants grow strong and produce high-quality heads. Depending on the variety, broccoli can be harvested 60 to 100 days after sowing, once the heads are large, tightly packed, and deep green. Around October each year, broccoli fields come alive with the hum of machinery and the swift footsteps of farmers entering harvest season. Thanks to advances in agricultural technology, there are now various methods for harvesting broccoli, depending on the size of the farm, weather conditions, and the desired quality of the final product. Harvesting broccoli by hand with the support of conveyor belts is an efficient blend of human labor and technology. Farmers, armed with sharp knives, walk along the rows like garden artisans, carefully observing and inspecting each head with intense focus. When a broccoli head reaches its ideal size, they swiftly and precisely cut it from the stalk. The highlight of this method is the mobile conveyor system that moves alongside the harvesters. Instead of carrying each broccoli head by hand or piling them on the ground, workers simply place them gently onto the conveyor belt beside them. The machine moves slowly, matching their walking pace, and steadily transports the broccoli to the rear, where large collection bins on a truck are waiting. On board, workers quickly arrange the heads into crates, stacking them neatly, in preparation for their journey to the processing facility. There is a special type of conveyor belt known as a cup conveyor. While more commonly used for cauliflower, this system can also be adapted to harvest large or delicate heads of broccoli. Each plastic cup on the conveyor securely holds an individual floret, allowing it to travel smoothly across the field without bruising, ensuring optimal quality for post-harvest handling. This design is especially suited for farms with neatly aligned rows, where gentle, precise harvesting is required to meet high export standards. The combination of human labor and machinery not only reduces physical strain but also significantly boosts efficiency. Thanks to the conveyor, each broccoli head is handled immediately after cutting, minimizing damage, reducing losses, and preserving peak freshness. However, on many smaller farms that can't afford such equipment, workers must carry baskets of cauliflower weighing 20 to 25 kilograms on their backs or shoulders, navigating dense vegetable rows under the hot sun. It's a tough job, with a wage of only $10 to $12 per hour. Would you be willing to give it a try? In areas with flat terrain, loose soil, and evenly spaced planting rows, row harvesting machines are an ideal solution for collecting both broccoli and cauliflower. These bulky yet highly precise machines are designed to harvest multiple rows of vegetables simultaneously, significantly saving time and labor costs. As the machine moves slowly across the field, a series of steel prongs at the front gently slide beneath the plants, lifting the stalks and separating the heads from the stems using high-speed rotating blades. Immediately after cutting, the florets are transported via an inclined conveyor belt directly into a storage compartment at the rear or onto a truck moving alongside. The unused leaves and stems are left in the field, where they can be repurposed as green manure or livestock feed. This entire process operates continuously with consistent precision, and under optimal field conditions, the machine can harvest dozens of tons of produce per hour. Compared to manual labor, it offers a productivity increase of 5 to 7 times, while significantly reducing labor costs throughout the harvesting season. This type of harvester is especially well suited for large-scale production and is widely used in countries like the United States, Spain, and Australia, regions characterized by concentrated agricultural zones and ongoing labor shortages in the farming sector. In recent years, a more advanced method has gradually appeared in the fields. Amid endless rows of broccoli, a self-propelled machine slowly moves forward, carrying a series of yellow robotic arms suspended beneath a steel frame. Each robotic arm is equipped with a gripper made of soft silicone fingers that gently handle the vegetables without causing damage. Notably, each arm is also fitted with a high-pressure misting nozzle that sprays a cold mist to instantly cool the freshly cut broccoli. This helps keep the vegetables fresh longer and limits bacterial growth during the early post-harvest stage. Immediately after cutting, the broccoli is lifted using an integrated vacuum suction mechanism and then transferred onto a conveyor belt or directly dropped into collection bins. Thanks to their ability to operate in a synchronized, continuous, and highly accurate manner, regardless of time or weather, these machines help address the labor shortage problem. However, the initial investment cost can be extremely high, reaching hundreds of thousands of dollars, not to mention maintenance expenses. Despite their advantages, they still face certain challenges. Though not yet widespread, this technology is gradually proving its value in high-tech agriculture, marking a significant step forward in the modernization of farming practices. As soon as the truck arrives at the factory, the raw broccoli is brought into the receiving area for strict inspection. Only the heads that meet standards for size, color, firmness, and freshness move on to the next stage. Damaged, bruised, or uneven heads are rejected on the spot to ensure only the best products are selected. After preliminary sorting, the broccoli is transferred to the stem cutting area, where special conveyor belts with a series of round holes are specifically designed for this step. Each worker gently places a broccoli head into a slot with the stem facing downward. Once it is securely positioned, an automatic blade system beneath the tray is activated, neatly trimming the stem to a standard length. In just a flash, the broccoli, now trimmed into uniform, firm florets, gently glides along the conveyor belt toward the automated sorting stage. Here, a system of cameras and sensors scans each head to assess its size, shape, and overall quality. Immediately after, mechanical arms or air jets gently guide the broccoli into different sorting lanes, large, medium, or small, according to market standards or intended use. For fresh broccoli intended for direct consumption, the heads are sent straight to the packaging line without undergoing further processing. Here, the vegetables are either vacuum sealed or packed in modified atmosphere bags to retain their moisture and crispness. Each package is clearly labeled with traceability information, packaging date, and expiration date. Thanks to a cold storage system immediately afterward, the products can remain fresh for 7 to 10 days under proper storage conditions. For batches of broccoli not intended for whole head sales, the florets are directed to the cutting stage to serve further processed products. In many factories, this step is still performed manually by skilled workers who use sharp knives to carefully separate each floret, ensuring the heads remain intact and undamaged. However, in larger processing plants, automated cutting lines are also used in parallel to boost productivity. These programmed machines divide broccoli into various sizes depending on the intended use, ensuring uniformity and minimizing raw material loss. Whether cut by hand or machine, the common goal is to produce well-shaped florets that are easy to package and suitable for a wide range of market demands. After cutting and sorting, the broccoli is transferred to the washing area, an essential step to remove soil, small insects, and pesticide residues. Instead of using high pressure, most factories employ gentle water sprays combined with a mobile mesh conveyor belt. Cold water is sprayed from multiple directions, enough to thoroughly clean without damaging the delicate florets. Maintaining low water pressure is a deliberate technical choice to preserve the shape and structure of the broccoli, which is crucial for commercial packaging. Some facilities also use ozonated water or diluted chlorine solutions to enhance sanitation effectiveness while remaining food safe. After washing, the broccoli is passed through a dewatering shaker. This equipment not only removes excess moisture but also separates out any remaining substandard vegetable fragments. As a result, the broccoli doesn't clump together during freezing, ensuring that each piece remains separate and of high quality. Once dewatered, the broccoli is transferred to an IQF, individual quick freezing system, where the temperature rapidly drops to -35 degrees within minutes. This quick freezing process preserves the cellular structure of the vegetable, maintaining its color, crunchiness, and nutritional value. Each floret or piece emerges from the conveyor belt individually frozen, not stuck together, ready for flexible packaging to suit various market needs. The entire batch is then stored in cold warehouses at temperatures ranging from -18 to 25 degrees while awaiting distribution. Each package carries a traceability code from farm to table, ensuring transparency and adherence to global standards in the modern frozen vegetable industry. Indonesia is known as the Kingdom of Palm Oil, producing over 51 billion bottles each year, accounting for 55% of global output. These vast palm plantations are not only the heart of Indonesian agriculture, but also bio-oil mines that sustain millions of livelihoods and supply raw materials to the world. Palm oil is astonishingly cheap, several times less expensive than soybean or olive oil, yet it's nutritionally rich, containing 3 times more beta-carotene than a carrot. And yet, behind the purity of every drop of palm oil lies an unending debate. The palm oil industry is both a silent pillar of modern civilization and a razor-sharp double-edged sword. On one side, it fuels the global economy. On the other, it raises serious concerns about environmental impact, human rights, and ethical responsibility. Labor in the palm oil sector is often linked to troubling abuses. Perhaps that's why it's called blood oil, an oil not only extracted from fruit, but also from sweat, tears, and at times, even human dignity. The magical journey of palm fruits, from their rough, spiky exterior to pure golden palm oil, begins in expansive plantations where they are carefully harvested. Only fruits that have reached peak ripeness can yield the highest quality oil. Today, harvesting can be done either manually or with mechanical assistance. In small-scale farms or hard-to-reach areas, manual harvesting is still preferred. Skilled workers often climb trees as tall as 6 meters, or use tools like long knives and poles to cut down bunches of fruit. A study in Malaysia revealed that 9.46% of palm plantation workers have suffered work-related injuries, 2 to 3 times higher than in the construction sector, and nearly 5 times the rate in transportation. Whether picked by hand or machine, the ripe red fruit bunches are swiftly loaded onto specialized trucks. These vehicles wind their way down dusty plantation roads, leaving behind palm-covered fields, carrying the fruits of human labor. Each truckload is a vital link in the journey, delivering the harvested fruit to factories, where it will be transformed into the coveted red gold. As soon as the trucks come to a stop at the factory gate, the palm fruit bunches are gently pushed off by a specialized loader. Using its large front bucket, the loader carefully scoops the ripe, crimson-red bunches onto an inclined receiving chute below. These heavy bunches begin to roll down the slope in a controlled manner to prevent bruising or damage to the fruits. At the end of the chute, the bunches drop into large conveyor hoppers waiting below. These hoppers, resembling mobile transport compartments, are deep and wide enough to keep each bunch stable during movement. From here, the fruits are gradually carried deeper into the factory, ready to undergo the next stages of processing to produce the rich, golden drops of palm oil. On its extraordinary journey, the palm fruit arrives at the factory for the cleaning phase. Here, the fruit is sterilized and disinfected using automated systems designed to eliminate impurities and harmful bacteria. This step also softens the fruit, making it easier to separate the kernel and extract the oil efficiently. Once cleaned, the palm fruit continues its journey through the separation and sorting stage. Each fruit is carefully classified, its pulp reserved for extracting crude palm oil, while the kernel, often called the seed of life, is separated for palm kernel oil production. The process begins with a bunch thresher, which uses centrifugal force and vibration to detach individual fruits from their bunches. The loose fruits are then fed into screw presses, where the mesocarp, fruit flesh, is crushed and pressed at controlled temperatures of 90 to 100 degrees Celsius to extract crude palm oil. Meanwhile, the inner kernel is sorted out using gravity and aerodynamic separation, and further pressed using vertical screw presses to obtain palm kernel oil. Here, precision in technology and meticulous classification determine the quality of every drop of oil produced. After the hard outer shell is removed, the palm kernels, containing the most valuable portion of oil, are transferred to a specialized sorting system. Here, machines use a combination of gravity and aerodynamic forces to separate the kernels that meet strict standards in size, weight, and cleanliness. These selected kernels then continue their journey to a vertical screw press, an apparatus that applies immense pressure to squeeze out the oil locked within each seed. This pressing process yields pure palm kernel oil while preserving most of the natural nutrients found in the kernels. It marks a crucial step in ensuring the oil's quality before it moves on to the subsequent refining stages. Like a key unlocking the treasure hidden within each palm fruit, oil extraction is a pivotal stage where nature's essence is transformed into golden liquid. The most common method is hot pressing, in which the fruit is cooked at high temperatures to release vibrant orange-red oil rich in natural nutrients. This is primarily carried out using screw press machines, the core technology in most palm oil factories. As the fruit is fed into the press, it is crushed and squeezed by a rotating screw shaft, applying pressure to separate the oil from the pulp. The temperature is carefully maintained between 90 to 100 degrees Celsius to break down the oil structure while preserving its valuable nutrients. The resulting crude palm oil has a distinctive color and high carotene content. However, to meet quality standards and application requirements, the oil must undergo a refining process to remove impurities and enhance its color, flavor, and stability. But the magical journey of the palm fruit does not end there. After the oil has been fully extracted, what remains, once deemed as mere waste, now opens a new chapter in the value chain. Once the essential oils are extracted from both the pulp and the kernel, a significant amount of organic residue remains, among which palm empty fruit bunches, EFBs, the fibrous oil-free stalks, account for a large portion. Previously considered worthless byproducts, EFBs are now being redefined as a highly promising biological resource. Right after being separated from the fruit clusters, the EFBs are collected and pressed to remove moisture. This reduces their weight, making transportation to processing sites more efficient. Here, they are transformed into useful products such as animal feed, biofuel, or construction materials. This process not only minimizes waste, but also contributes to building a more sustainable palm oil industry, where every drop of oil is not merely a product of extraction, but a symbol of a closed-loop life cycle. Once the treasure trove of essence is unlocked, crude palm oil must embark on one final journey before reaching true purity. Though it can be extracted right after pressing, its deep orange hue and strong, pungent aroma often push people away at first encounter. The palm oil refining process consists of 4 main steps: neutralization with NaOH followed by warm water washing, decolorization using activated clay at 90 to 110 degrees Celsius, deodorization with superheated steam at 200 to 260 degrees Celsius under deep vacuum, and cooling to 20 degrees Celsius to crystallize and separate stearin, leaving behind a clear, pure layer of olein. Crude palm oil is like a ripe fruit, vivid, rich, yet raw and untamed. Refined oil, in contrast, resembles filtered essence, pale, sleek, and pure, but with only a hint of nature's original character. Once refined, the palm oil is directed to a fully automated packaging line. On high-speed conveyor belts, the oil is precisely filled into bottles, at speeds reaching up to 1,000 units per minute. The caps are immediately sealed using automated systems to ensure airtight preservation and prevent contamination. Next, smart sensors guide the automated labeling process, ensuring both accuracy and visual appeal before the bottles are boxed and dispatched. Finally, the packaged bottles are automatically stacked into cartons, ready to begin their journey to millions of homes, each carrying a mission.